Okay, welcome back. So hopefully it is clear what we're going to do. So now first, let's work in the geometry. Okay, so let me go here. We have the scripts. Let me open this one. Okay. Also, from time to time, you have this readme. There are some comments. So, but here we don't need it. So let me close it. And this is our script. So let's go through what we're going to do. So very important. I'm running all cases with 28 cores. In your case, please change this number, okay, according to your core. So this will automatically update everything. So if you have 4 cores, it will be up to you. So, but be careful about that. Otherwise, now you will slow down things. If you don't have the cores, you have the cores, go ahead. We're going to use here the cores mesh. So as you're going to see that you have 2 folders, cores and then find, okay, different meshing setups, just meshing setup. Okay, so if you want to go to define, feel free. Okay, it's a much finer mesh, okay, nicer, but I will keep things low. Okay, I will work with the cores. Then okay, you keep reading. So these are steps about if you want to convert features. I think we covered here in another video, but don't worry, later I will dedicate something about these features when selecting paraview, if you have object file, how to convert an object or STL to image and so on, or BTK file. Surface check, there are many tools in OpenFOAM to do surface check. I recommend you to use, okay, so I put in some things there, some comments if you want to check your geometry, but now in paraview also we have something similar, okay, but it's up to you. And then here's where we have the geometry. So we are reading the body, the fuselage, and then we read different propellers. This one, they are not used, even though we are going to use it, they are not used in the setup. And then here you have the mesh generation, okay? Extract the edges. So remember, you have in your snappyHexMesh, you can do first read geometries, then do the mesh refinement, okay? The mesh refinement, it is in edges, surfaces, and the volume. After you have that edge refinement, it's a Cartesian mesh, you move and you do the snapping, the body fitted mesh, and at that point you are ready to go. You can run in that mesh, but it's always recommended to add a couple of boundary layers. We're going to see the reason why is that, but it's up to you. But even the Cartesian mesh, the first set is a valid mesh, but it's a Cartesian, so it's not going to resolve very well the boundary layer. So here also check mesh to write faulty sets, then get the groups of faulty sets. So probably when you run this automatically, you're going to see some errors or warnings because this set doesn't exist. Okay, I put everything out to have. Here the automatic renaming. So remember that we have the background mesh with some names, and here I'm changing just those names now here. Max, min, X, and outlet, inlet, and so on, and groups, so those automatic renaming. So as you see, this is everything is parameterized, so ready to put it in your tool chains and do larger study chains, different variables. Okay, so I tried to remove human intervention for all these scripts, and some other here, well, in this case, create patch just to delete empty patches if there are empty patches. So this is it. So very easy. So this mesh, there is no boundary layer. You have the other script, okay, the run mesh BL that will add the boundary layer. Okay, so override will overwrite it. Remember that if you are going to analyze different combinations, I recommend do not use the override option, and then you're going to have that next fault directory, 1, 2, or whatever, and then you can check that mesh is okay, and then if you are satisfied, you take it as a good mesh. And that's it, okay? And then run the solver, that's all. So this is our scripts, okay? And now let's take a look. So in case it's ready to run, okay? I'm not going to visit all standard boundary conditions, okay? I'm not going, or probably when we go to the solver, we visit that, also the case setup here. But let's focus on the meshing, now that is our interest. So coming back here, we're using what dictionary? So be careful what we're using this dictionary, the body, okay? Only the body, the fuselage. And let's open. So look at our steps. So remember that the snappy works in 3 consecutive steps. So first castellation or Cartesian mesh, then the snapping, and then you add your boundary layer. So it's up to you to enable everything at the same time or do one at a time. Personally speaking, new geometries, since are tricky, I like to do everything one at a time. So first the castellation, I check that everything is okay, and then I go enable snapping and put this to false and so on. But in this case, let's do step 1 and 2 at the same time, and then later we do the add layers. So remember the first things. So here, let's demystify, because usually new people open the snappyHexMesh and get crazy, you know, because there are so many options and comments. So I keep it here very simple. So just to point out that here you can have different entries. So remember, in other videos we talk about that you can read your STL, but then also you can get access to those subpatches that you have in the STL. Now you have the body keyword and so on. You can access those here inside. It can be very tricky. Even though we have access to that information here, I don't access. Okay, I prefer to have separate files or to avoid that, to avoid complications. So here it's very simple. Fuselage, your propeller, we know which propeller we're using. Everything is coming from here that I'm doing that renaming and moving files. Then that's all here. This is the box to do the refinement. That box is equivalent to this box that you see here. Okay, so I like always to work in a CAD tool. In this case, I use onshape, and well, kudos to the developers of onshape. It's a fantastic tool, and I get my coordinates here. So the coordinates that you see here corresponds now to the coordinates of that box, and that's all. Okay, so you read your geometries, and then you go to castellation. This is the Cartesian mesh. Okay, so in castellation is where you add the refinement in points, lines, surfaces, and volume. Okay, so the first, I move things around here. Okay, so I put all your keywords, the parameters at the beginning. So this is very standard for me. I don't change it. The only thing that I can change here is probably the maximum number of cells. That here is already set to 100 million, which is high, but if you want to have more cells, just increase it or reduce it. So remember that this will put a limit in the maximum numbers of cells. So if you put here something like this, you know that your mesh is not going to be very good. Maximum set of 10,000. Okay, so you're already putting there a limit. So be careful about that. But for me, it's very standard, self-explanatory, nothing to do, and we cover plenty all these options in previous videos. Then we go to features. Features are the edges. Okay, so this is up to you if you want to capture edges. So let me go back. Edges can be this hard edge here. Okay, in this case now we don't want to capture that, but if we look at the geometry, for instance, leading edge, okay, those are edges. Okay, here in the blade propeller and so on. Here the intersections also can be considered as hard edges. So if you want to capture all those edges, you need to have the surface features. And I was already mentioned now that snappyHexMesh is actually a good measure. Now for dirty geometries, it works very well. Okay, sometimes it will have problem capturing these edges, but for instance, if you take this geometry without intersection, it will give you a good mesh. The issue will be that these features, all these edges are not captured very well, so that's why you need to use surface features. Okay, but it's a very good measure. Okay, I like it up to the point of the boundary layer. Boundary layer is the tricky part where we have seen some tricks. But here the idea of those features is just to capture that. So we use a command surface feature that we have here. Okay, so I'm going here in the details in this video. The next one I'm not going to recover here, but just to clarify everything. So surface features, we should have it here. Capture that, and that will read another dictionary here and telling just read the propeller, body, all the geometry. It has those features there, and then use it according to some parameters. So see that, read the body and just enforce the snapping to those edges. Then the propeller the same, enforce, and that's all. The rest is commented. Something as well I commented that 0 will enforce that. But then you can increase that number, and you can use, for instance, in this case, in the propeller, you can use 10. In theory, we'll use a refinement of 10, but this option, personally speaking, doesn't work very well in my personal experience. So it's better to use levels. Okay, levels work fantastic, and actually this is the one I use. Okay, when I want to add refinement, if I want to enforce the snapping, 0 is more than enough. So levels means that the first number is the distance from those features, and the second it is the refinement. So here I'm telling a distance of 0.02 meters from those features at a refinement of 10. And remember, you know your geometry. Okay, you know you can measure, you know what are those 0.2 meters, and it's up to you. The second one that you see here, it is two refinement levels. Okay, so first one, a distance 0.01 at a refinement of 12, and the second, a distance of 0.02 at a refinement of 10. So you add different levels. So you go from the closest to the farthest from the bodies. This is how you put it. So it's up to you, okay? But in this simple case, let's do the skid sense fast. So just snapping. So these are your feature segments. And now we move to refinement surfaces. Okay, refinement surfaces refers to the surfaces, the geometries that you are reading here or you are defining here. So in this case will be body and prop. Okay, we don't have the rotating zone. So there you go, body at refinement level of 6.6. Okay, remember the second one is for curvature, so where you have more curvature, it will add more refinement. So in this case will be 8, and that refinement is controlled by this parameter. By this parameter. The lowest this value is, the more refinement due to curvature will add. Okay, so this is the deviation now from that triangulation. Okay. It's up to you. So in this case, I usually use it 30, and here let me leave it 6.6. So it's up to you. Then the rest is very standard from the propeller. Also, I'm using a larger refinement AA. It's a smaller feature, so obviously I need to add more. So it's not going to be a very nice mesh, but we're going to get the idea. Okay, then you put 1010, that will be okay. Then you have this section is completely commented. So in the next, when we start to talk about moving reference, multiple reference frames or sliding meshes, this will become handy. But this is just to create sums. So for the moment, it's commented, and we don't need it. And then we go to regions. Okay, volume regions or refinement from the surface. So basically, we have the refinement box. Inside that box, do a refinement of 2, and remember that box will be that box. No, that is the domain. That is the domain. Will be that one. So inside that box, do a refinement of 2. Then you have the other options. Now the rotating zones, you want, we're not using that. And here we have this here, the prop. So one thing that this refinement we also mentioned, now doing a surface refinement on top of a surface. Okay, so the best way to do it is to do it here in region refinement. That is by using the option levels that work similar to the features. So you select a surface, not necessarily, in this case it's the same as the prop that you are reading here now. But you apply in that specific surface a distance refinement and a distance normal to that surface, apply that refinement. So it's better to do it like this, okay? I'm not going to use it, but as I mentioned, that is refinement on top of a refinement. And that's it. That is your refinement. Then location in mesh, a point that it have to be inside your domain. So let me put it here. But outside of the STL, if you want external geometry. Now in this case, it's external, so it's a point somewhere there. So be careful not to put that point precisely on the STL. Okay, so be careful about that. And those are your options now for the refinement, now for the castellation. As you see, very straightforward. You don't need to get lost. I want to remind you also that each of here in refinement also you have some other options. You have a sub dictionary that you can define patches and so on. I erase everything. I'm not using those options. It can be confusing. I have it as easy as possible. Remember also we studied, in one of the optional tutorials, this gap level increment. So if you want, you can add it locally or globally. So in this case, you put it, it's not going to make any difference because you don't have closed gaps, but okay, if you want. Okay, I try to avoid this option because it can increase very fast your mesh and sometimes give you bad quality cells. So at this point, you are ready. Now you can generate the castellation, and then remember the castellation as a Cartesian mesh, and then we have the snap control. This is the snapping. These are the options. We have discussed this a lot, and these are my standard options. most of the time it works fine. Sometimes you have problems snapping. Try just to double the quantity. So most of the time the problem is feature snapping. So probably you increase to 20, then 40. You might improve that, but not necessarily. For sure, the meshing time will be longer, but not necessarily you are going to get a much better mesh. And sometimes if you add too many iterations, you can get the mesh will be worse. Okay, so this is it. We have all the parameters. We know what we're doing here. This is very important. This we're going to understand better this one in multiple reference thresholds like the meshes. And here we don't have any boundary layer, so nothing there. Mesh quality parameters, and that's all. So let me open here, mesh quality parameters, and these are the ones I'm using for volume surface refinement. Then boundary layer, which is this one, will require some others that later we're going to discuss those parameters. So at this point, let's do the mesh. Okay, so let me go Cessna, no sounds, run mesh, sh, and it will do everything. So remember, it will also compute the features, and so also if you want open paraview, we have seen also how to look at those features, visualize, get a visual reference, and so on. So the features are safe here, or you can use the filter in paraview. So it's X meshes, so you will open body X meshes and you will see all those features. So while running, it's very important, always save the log file and take a look what is happening here now, because it's OpenFOAM is continuously now also checking mesh quality. Look at that, when all those iterations is trying to enforce the mesh quality. So usually castellation, okay, the quality should be perfect. See that you don't have any non-orthogonality. Okay, so usually you get it like this. If you are running and you see that in castellation you get bad quality elements, be careful that there is something wrong there, but usually castellation, they should be very good quality. Then when you move to the snapping phase, you start to do the snapping from the surface, not from the Cartesian mesh to the surface. There is where you start to see now that you have a few cells that are not satisfying these quality criteria that you are defining here, okay? But usually there are not many. Now when you do the surface, the problem starts to become problematic in the boundary layer. Later we're going to study better. But look at that, after 5-6 iterations, everything is perfect. You are just satisfying all those quality metrics, and that's it. Okay, we have all the checks and we have a valid mesh. Let me go here, paraview build int, and let's take a look at the mesh, the body mesh. And first, let me go that I have here load state, and should be paraview mesh, have a state there, and let's take a look at the mesh. And there you go. So these are the cut planes. So see that is a very nice refinement, okay, around the body. Then if you want, we can plot in the body later. Let's do that. Let me put it here. And recall that we use a finer mesh in the propeller, and there you have the parameters. Then here, so it's not super nice, okay, but get the idea. Increase the refinement surface, and it will be a much better mesh. So this is, let's say this mesh is valid. Then the next step, we're going to do the boundary layer, but just to point out that something critical. So you look at this one, and you can use this simulation to run, this mesh to run a simulation. See that you have this cell collapsing on the surface. This will introduce an error that later we're going to see, and that error definitely you need to fix that, okay? I don't recommend you to have those solutions. That is horrible, that is very bad. So later when we run, you're going to see, but look at that, this collapsing is bad. So the idea, remember, close to the surface, you want to have the mesh orthogonal to the surface. And in these points, the mesh is not orthogonal. So that orthogonal mesh, we can add it by adding the boundary layer, okay? So just one single inflation layer will be enough, but my advice is to add 3, okay? If you don't want to add too much, but if you want to go crazy and put 20, 30, it's up to you. But 3, it would be more than enough to have a perfect orthogonal mesh to the surface. Okay, so this is our first mesh. Okay, so let me stop the video here. Digest, practice, try to change all parameters to get different, different meshes. It's up to you. And in the next video, let's work in the boundary layer mesh. So thank you for your attention. See you in the next video. Bye.